Light reflection and refraction. Part 1. Light. What is light? Light is made up of electromagnetic waves which produce the sensation of vision in us. An electromagnetic wave is a wave made up of oscillating electric and magnetic fields. This electromagnetic wave oscillates in mutually perpendicular direction and also perpendicular to the path of propagation of the wave. According to quantum theory, light is transmitted as tiny bundles of energy called photons. Wavelength of the visible light ranges from 400 to 700 nanometers. Speed of light is defined as the speed at which light propagates through medium. The value of speed of light in vacuum is 3 × 10⁸ meter per second. What is a ray of light? Ray of light is a path along which light energy travels in a medium. It is represented by arrow on a straight line. Arrowhead represents the direction. What is a beam of light? A group of rays is called a beam of light. Narrow beam is called a pencil of light. Based on point of meeting and width of the pencil, a beam can be of 3 kinds. A. Parallel pencil. B. Convergent pencil and C. Divergent pencil. Beam of light can be parallel, convergent, or divergent. Parallel beam, rays from a distant light source like the sun are parallel to each other. Convergent beam, in convergent beam the ray proceeds towards a point, divergent beam the ray proceeds away from a point. What is a mirror? A highly polished surface which is smooth enough to reflect a good fraction of light incident on it is called a mirror. Common types of mirrors are plane mirror, concave mirror and convex mirror. What is reflection of light? When light traveling from one medium falls on the surface of another medium, a portion of incident light is turned back into the first medium. This is called reflection of light. What is a source of light? A source of light is an object which emits light. Source of light can either be natural or artificial. The natural sources of light are nuclear fusion, sun and stars. Bioluminescence light produced by chemical reactions within the organism, e.g., fireflies, jellyfish, glowworm. Natural events like lightning and volcanic eruptions. What are the artificial sources of light? There are 4 types of artificial sources of light. Incandescent sources of light, luminescent sources of light, gas discharge sources of light, and LED bulbs. In incandescent sources of light, objects are heated to a high temperature to emit light. Both infrared and visible light is produced in the process. Example, incandescent lamp, candle. In luminescent sources of light, light can be produced by passing electricity through a luminescent material as in fluorescent bulb or fluorescent tube light. In gas discharge sources of light, light can be produced by passing electricity through certain gases at very low pressure. Example, vapor lamps like neon lamp and sodium lamp. In LED or light-emitting diode, light can be produced by passing electricity through a semiconductor, which gives off visible light. E.g. LED bulb or light-emitting diode or LED strips. What is an optical medium? An optical medium is a substance through which light can pass. There are 3 categories of optical medium: transparent, translucent and opaque. Transparent medium is a substance through light can pass through easily and objects can be seen clearly. E.g. air, water, glass. Translucent medium is a substance through which light passes partially and objects are not clearly seen. E.g. paper, plastic, glass. Opaque medium is a substance which do not allow light to pass through. E.g. wood, metals, rubber, etc. What happens when light falls on the surface of another medium? It either reflects or refracts or absorbs. Where a part of the incident light is turned back into the first medium, this is called reflection of light. Where a part of incident light is transmitted through the second medium and bends from its path at the surface of separation, this is called refraction of light. The remaining part of incident light is absorbed at the surface of separation. This is called absorption of light. What is an incident ray? The ray of light which falls on mirror's reflecting surface is called the incident ray. What is a reflected ray? The ray of light which is sent back by the mirror is called the reflected ray. What is point of incidence? The point at which the incident ray strikes the reflecting surface of the mirror is called the point of incidence P. What is normal? The normal is a line drawn at right angle, perpendicular, to the mirror surface at the point of incidence. What is angle of incidence? The angle which the incident ray makes with the normal at the point of incidence is called the angle of incidence. What is angle of reflection? The angle which the reflected ray makes with the normal at the point of incidence is called the angle of reflection. What happens when a ray of light falls normally, at right angle, on a mirror? The incident ray and reflected ray coincides with the normal, meaning it is reflected back along the same path. Angle of reflection is 0. Under Cartesian sign conventions for spherical mirror, 1 incident light is shown coming from left-hand side of mirror. 2 all distances are measured from the pole of the mirror. 3 distances towards left-hand side of mirror are taken as negative and those on right-hand side are taken as positive. 4 the height is measured perpendicular to the principal axis. 5 distance above principal axis is taken as positive. 6 distance below principal axis is taken as negative. Before we move further, if you are new here, please subscribe to the channel and press the bell icon to get notification of new lessons and MCQs. If you like the content we make, please like the video by giving it a thumbs up and share the video with your friends and classmates. Light Part 2. Let's learn about mirrors. What are the different types of mirrors? The most common type of mirrors are 1. Plane mirror and 2. Spherical mirror. In spherical mirror there are A. Concave mirrors and B. Convex mirrors. What is a plane mirror? A plane mirror is a mirror with a flat reflective surface. What is the nature of the imager formed by a plane mirror? An image in a plane mirror is different from you. The left of the object becomes the right of the image and vice versa. It is due to lateral inversion that it is difficult to read text reflected by a plane mirror. What are the characteristics of image formed by plane mirror? SS, SD, Li, BE and V. They are same size, same distance, laterally inverted, behind the mirror, erect and virtual. What is reflection? Reflection is the phenomenon of bouncing back of the rays of light when they fall on an obstacle. It is similar to the bouncing of a ball when we throw it on a rigid surface. When light rays fall on an object, some of them are reflected, some pass through it and the rest of the light rays are absorbed by the object. Laws of reflection. When light falls on a smooth reflecting surface, 1. The incident ray, the normal and the reflected ray, all lie in the same plane. 2. The angle of incidence is equal to the angle of reflection. Angle I is equal to angle R. The laws of reflection are applicable to all types of reflecting surface even in diffuse reflection situations. What are real and virtual images? Real image. If the beam of light converges or intersects, then the image is called real image. Real images are inverted and real images can be obtained on a screen. Virtual image. If the beam of light diverges or do not intersect, then the image is called virtual image. Virtual images are erect. Virtual images cannot be obtained on a screen. Light Part 3. Let us understand spherical mirrors. What are spherical mirrors? A sphere is a perfect circle in 3 dimensions, like a bubble. Spherical mirror's reflecting surface forms a part of a hollow sphere. The reflecting surface could be either inside or outside of the sphere. Concave mirror. How to draw a concave mirror? First, use your scale to mark 3 points equidistant from each other vertically. Next, join the top and bottom points together with the help of your protractor. Then draw a horizontal line through the middle point and mark it as the principal axis. The point where the principal axis intersects the mirror will be the pole. Mark it as the principal axis. Mark the reflective and non-reflective parts. Remember, this mirror is part of a bigger sphere. Mark its center. The distance from the pole to the center is the radius. Half of the radius is the focus. In this circle we can see that more than one radius are marked. Ray diagrams. In ray diagrams, to locate the image of an object, a large number of rays could be considered. But we use just 2 rays. The intersection of 2 reflected rays gives the position of image of the object. Ray diagrams. Any 2 of the following rays can be considered for locating the image. 1. A ray parallel to the principal axis, after reflection. On concave mirror it will pass through the principal focus. On convex mirror it will appear to diverge from the principal focus. 2. A ray directed to the focus. On concave mirror or convex mirror, will emerge parallel to the principal axis. 3. A ray directed at the center of curvature. On concave mirror or convex mirror, after reflection, is reflected back along the same path. 4. A ray oblique to the principal axis, towards the pole of the mirror. On concave or convex mirror, is reflected obliquely, making equal angles with the principal axis. What is a real image? If a beam of rays starting from a point source of light after reflection or refraction actually converges to a point, then the second point is called the real image of the first. A real image is inverted and can be obtained on a screen. What is virtual image? If a beam of rays starting from a point source of light after reflection appears to diverge, then the second point is called the virtual image. If a beam of rays do not intersect each other after reflection, then the image produced is virtual. A virtual image is erect and cannot be obtained on a screen. What are the characteristics of image formed by concave mirror? The object placed at different locations will produce image at different locations. When the object is at infinity, the image formed is highly diminished, point-sized, inverted, and formed at the focus. When the object is beyond C, the image formed is diminished, inverted image and formed between C and F. When the object is at center, same size and inverted image is formed at C. When the object is between C and F, the image is enlarged, inverted, and is formed beyond C. When the object is at focus, the image is enlarged, inverted and formed at infinity. When the object is between F and P, the image is virtual, erect and enlarged, and the image is formed behind the mirror. When the object is at infinity, the image formed is highly diminished, point-sized, inverted, and formed at the focus. When the object is beyond C, the image formed is diminished, inverted image and formed between C and F. When the object is at center, same size and inverted image is formed at C. When the object is between C and F, the image is enlarged, inverted, and is formed beyond C. When the object is at focus, the image is enlarged, inverted and formed at infinity. When the object is between F and P, the image is virtual, erect and enlarged, and the image is formed behind the mirror. Concave mirrors are used as reflectors to disperse light beams in torches, searchlights, and vehicles' headlights. Concave mirrors uses the power of converging sunlight in solar furnace. It is also used in dentist mirrors. Convex mirror. Convex mirror is simple because it has just two positions where objects can be placed. This is because focus and center of curvature lie behind the mirror. Thus the object can be placed only at two places: A, at infinity, or at B, between infinity and pole. If object is at infinity, then the image is produced at focus. If object is between infinity and pole, then the image is produced between P and F. Convex mirrors are used in sunglasses to reflect sunlight away. It is used in rear view mirrors of vehicles as the image produced is smaller. It is also used as security mirrors in ATMs and tight corners to warn about oncoming people or vehicles. In a spherical mirror, the focal length is called F. Radius of curvature is called R. Focal length is half the radius of curvature. Focal length is always measured from the pole. Distance of object from pole is called U. Distance of the image from pole is called V. There is a relationship between these three quantities given by the mirror formula, which is expressed as 1 by F is equal to 1 by V plus 1 by U. What is image magnification for mirror? Linear magnification, M, is the ratio of the size of the image to the size of the object. In a concave mirror, remember that for real and inverted image magnification is always negative. And for virtual and erect image magnification is always positive. In a convex mirror, the image magnification is always virtual, erect, and positive. In spherical mirror, remember for magnification the virtual is positive, and real is negative. The image magnification formula for mirror is magnification is height of the image divided by the height of the object. Therefore M is equal to height of image by height of object. Magnification is equal to the ratio of image distance to that of object distance. M is equal to minus V by U. Light Part 4, Refraction. What is refraction of light? When a ray of light passes from one transparent medium to another, it bends from its path at the surface of separation. This phenomenon is known as refraction of light. Emergent ray O is parallel to the incident ray. Refraction of light through a glass prism. When a white light ray falls on the surface of a prism, light rays of different colors get refracted at different angles. What is optical image? When a beam of rays, starting from a point source of light, suffers a change in direction due to reflection or refraction, and the reflected or refracted rays actually converge to, or appear to diverge from another point, then the second point is called the image of the first point. In other words, optical image is the reproduction of an object, formed by a lens or mirror system from reflected or refracted light waves. An optical image may be real or inverted. Cartesian sign convention for spherical lenses. All distances are measured from the optical center of the lens. All distances measured in the direction of incident light are taken positive. The distances measured in the opposite direction of incident light are taken negative. Heights measured upwards and perpendicular to the principal axis is taken positive. Heights measured downwards and perpendicular to the principal axis is taken negative. What are the two laws of refraction of light? 1. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence, all lie in the same plane. 2. The ratio of sine of angle of incidence and the angle of refraction is a constant. This is also known as Snell's law of refraction. If I is the angle of incidence and r is the angle of refraction, then sin I by sin r will be equal to constant. This constant value is called the refractive index of the second medium with respect to the first. The refractive index variable is most commonly symbolized by the letter n in mathematical equations. Speed of light. Light propagates with different speeds in different media. Light travels fastest in vacuum with speed of 3 × 10 raised to the power of 8 meters per second to the power of -1. In air, the speed of light is only marginally less, compared to that in vacuum. But the speed of light reduces considerably in denser medium like glass or water. What is refractive index? The refractive index determines how much the path of light is bent, or refracted, when entering a material. This is described by Snell's law of refraction. Consider a ray of light traveling from medium 1 into medium 2. Let V1 be the speed of light in medium 1 and V2 be the speed of light in medium 2. The refractive index is represented by the letter n. The refractive index of medium 2 with respect to medium 1 is given by the ratio of the speed of light in medium 1 and the speed of light in medium 2. The refractive index can be expressed in an equation form as speed of light in medium 1 over speed of light in medium 2. Therefore n is equal to V1 over V2. What is absolute refractive index? The absolute refractive index of a medium is considered with respect to vacuum. If the reference medium 1 is vacuum, then the refractive index of medium 2 is considered with respect to vacuum. It is simply represented as n2 and is called the absolute refractive index of medium 2. If c is the speed of light in air and v is the speed of light in the medium, then, the refractive index of the medium nm is given by refractive index n is equal to speed of light in air over speed of light in medium 1. Thus n is equal to c by v. The absolute refractive index of a medium is simply called its refractive index. The refractive index of water equals 1.33. This means that the ratio of the speed of light in air and the speed of light in water is equal to 1.33. Similarly, the refractive index of crown glass, Ng equals 1.52. The refractive index of air is 1.0003, of ice is 1.31, of water is 1.33, of alcohol is 1.36, of kerosene is 1.44, of sapphire is 1.77, and of diamond the refractive index is 2.42. An optically denser medium may not possess greater mass density. Example, kerosene has higher refractive index, 1.44, than water, 1.33. Its optical density is greater than water, but its mass density is less than water. Part 5 Lens. What is a convex lens? A lens can have one or two spherical surfaces. Convex lens. A lens with two spherical surfaces, bulging outwards is called a double convex or biconvex lens. It is also commonly called a convex lens. It is thicker at the middle as compared to the edges. Convex lens converges light rays, hence are also called converging lenses. What is a concave lens? Concave lens. A lens with two spherical surfaces, curved inwards, is called a concave lens. It is also called a double concave or biconcave lens. It is thicker at the edges than at the middle. Since these lenses diverge light rays, they are also called diverging lenses. What are centers of curvature of a lens? The center of a sphere of part of which a lens is formed is called the center of curvature of the lens. Concave and convex lenses are formed by the combination of two parts of spheres, therefore they have two centers of curvature. The center of curvature of a lens is represented by the letter C. Since there are two centers of curvature, they are represented as C1 and C2. An imaginary straight line passing through the two centers of curvature of a lens is called its principal axis. The central point of a lens is its optical center. It is represented by the letter O. A ray of light passing through the optical center of a lens passes without suffering any deviation. Why do lenses have two focus? Since light can pass through a lens in either direction, a lens has two focal points, one on each side. Therefore, a lens has two principal foci, focus 1 and focus 2. The center of curvature or radius is twice the focal length. What is aperture of a lens? The effective diameter of the circular outline of a spherical lens is called its aperture. What happens when rays of light pass through a convex lens? When several rays of light parallel to the principal axis fall on a convex lens, these rays, after refraction, converge to a point called focus on the principal axis. What happens when rays of light pass through a concave lens? When several rays of light parallel to the principal axis fall on a concave lens, these rays, after refraction, appear to diverge from a point called focus on the principal axis. Image formation of convex lenses. When object is infinity, highly diminished, dot-sized image is formed at focus. When object is beyond 2f, diminished, inverted, real, image is formed between focus and 2f. When object is at 2f, same-sized, inverted, real, image is formed at 2f. When object is between 2f and f, radius and focus, enlarged and inverted, real, image is formed beyond 2f. When object is at f1, enlarged and inverted, real, image is formed at infinity, rays are parallel to each other and thus expected to meet at infinity. When object is between focus and optical center, enlarged and erect, virtual, image is formed behind the lens and object, rays are diverging and imagined to meet behind the lens if the rays are extended backwards. Once again, when object is infinity, highly diminished, dot-sized image is formed at focus. When object is beyond 2f, diminished, inverted, real, image is formed between focus and 2f. When object is at 2f, same-sized, inverted, real, image is formed at 2f. When object is between 2f and f, radius and focus, enlarged and inverted, real, image is formed beyond 2f. When object is at f1, enlarged and inverted, real, image is formed at infinity, rays are parallel to each other and thus expected to meet at infinity. When object is between focus and optical center, enlarged and erect, virtual, image is formed behind the lens and object, rays are diverging and imagined to meet behind the lens if the rays are extended backwards. What size images are formed by convex lens? In convex lens, inverted image can have all three size, either enlarged or same size or diminished, while an erect image can have only enlarged size. In a concave lens, the object can be placed at just two positions, either at infinity or at a finite position. When object is placed at infinity, a highly diminished image is produced at focus. When object is placed at any other finite position, a diminished, erect and virtual image is formed between focus and optical center. Let's repeat. In a concave lens the object can be placed at just two positions, either at infinity or at a finite position. When object is placed at infinity, a highly diminished image is produced at focus. When object is placed at any other finite position, a diminished, erect and virtual image is formed between focus and optical center. The magnification of an image can be measured by its distance or by its size. To measure magnification by distance we can use the formula of 1 by f is equal to 1 by v, minus 1 by u. Where f is the focal length, v is the image distance and u is the object distance. The magnification of an image can also be considered as the ratio of height of the image and the height of the object. Magnification is represented by the letter m. And can be measured as m is equal to the height of the image by the height of the object. This is also equal to the image distance by the object distance. Thus m is also equal to v by u. To summarize it all, m is equal to height of image by height of object and m is also equal to image distance by object distance. Thus magnification can be derived by size or by distance. When the image formed is erect, magnification is positive. When the image formed is inverted, magnification is negative. For spherical lens always remember, virtual is positive and real is negative. Power of a lens. The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. The power of a lens is defined as the reciprocal of its focal length. It is represented by the letter p. The power p, of a lens of focal length f, is given by p equal to 1 by f. The SI unit of power of a lens is diopter. It is denoted by the letter d. If f is expressed in meters, then power is expressed in diopters. Thus, 1 diopter is the power of a lens whose focal length is 1 meter. 1d equals 1 m minus 1. Power of a convex lens is positive and that of a concave lens is negative. If a number of lenses are placed in contact with each other, then the net power of the combination is equal to the algebraic sum of their individual powers like p equals p1 plus p2 plus p3 plus and so on.
Thank you for watching. Hope you like this video. If you do like, then please give it a thumbs up and share the video with your friends and classmates. If you are new here, do subscribe to the channel and press on the bell icon so that you will not miss out on the latest lessons and MCQs.